I'm going to look at lesson 113 of Symmetry of Solids with a couple of props. So the first one I want to look at, all right, is a cylinder. Now what plane symmetry is, plane symmetry is, say we have a cylinder and it can be sliced horizontally or sliced vertically. And if it was cut, the same shape would result. So if I have my cylinder right here and I cut it horizontally, right? Trying to guide it properly. I cut it horizontally. Well, my resulting shape, if I cut it in the center, is going to be the same shape if I was to open it up. Same thing if I cut it vertically, right? I would have the same shape. That is what's known as plane symmetry. And you've seen that before in, two-dimensional, right? You can cut a triangle. Boom, that's symmetry. Folds in half. It actually has that symmetry as well. But now we're just doing it with a three-dimensional figure. So that's plane symmetry. Now let's talk about rotational symmetry. So let's look at a cube. We've got a Rubik's Cube here. What it wants to know is, okay, how much rotational symmetry does this cube have? Well, since it's a regular polyhedron, meaning all the sides, edges, everything is equal, it will have it. What rotational symmetry means is, okay, how many times can I turn it? All right, so consider this right here, our initial point. Well, I can turn it once, twice, 3 times, 4 times before, if you see the little blue dot, I get it back to my original starting point. So what that's known as, if it has 4 rotations, that's known as an order of 4. Now, how many times did we rotate it? Well, when you're rotating overall, you're doing it 360 degrees, right? So we're going 360 full degrees. But how many times was when we did each rotation, how many degrees did we rotate it? Well, if it had an order of 4, we would simply divide 360 by 4 and figure out our rotational symmetry. So obviously 90 degrees. Notice that the amount of degrees is the size of the angle. So that is how you do rotational symmetry and plane symmetry for three-dimensional figures.